Hi folks, Mr. Long here. We're going to do a screencast on solving 3 by 3 linear systems. So that means 3 equations, 3 unknowns. And in this case, we're going to use x, y, and z as our variables. So, you've gone through the introductory video, so you kind of get a sense of our strategy. So I'm going to start with some really easy ones. So one thing I want you to notice is, so look over here. So your equations are going to appear right beside where you enter in the numbers. So what you'll have to do is enter in your numbers into this matrix, right? So this represents your x coefficient, right? That's going to be your y coefficient. Those are your z coefficients, and that's the constant that occurs at the end, right? So 1x, 5y, 4z equals -7. Now, the goal is this, to get zeros in those two entries, okay? Or these two, or these two. That in and of itself is not the reason. The reason is you want to have 2 equations and 2 unknowns for row 2 and row 3. As long as you've got just 2 equations with 2 unknowns in the second and third row, then you can solve it. It's a 2 by 2 system that you solve. And once you get those 2 answers, you can back substitute into the first row equation to get the third variable. Okay, so when you have a system like this, what you're going to do is first of all, you look at that when you've gotten everything in there, and remember that you want to put, if you've got a leading 1, and a leading 1 means a coefficient of 1 either in x, y, or z, you want to put that in the first row, okay? Unless you've got a 0 in that row. You'll see as we go through it, there's so many different permutations and combinations, but if you have only 2 equations with 2 unknowns amongst the 3 equations, you put those in the second 2 rows, okay? If you have this situation right here with 2 equations and 2 unknowns, you jump down to what I call part C, which says start here if your equation had a 2 by 2 system within it. So what we do here is we need to take this matrix C here, right? And you can just copy it. Control C, copies, and then paste. I think I've already done that. So I had done that already. Okay. So, and you enter that manually or cut and paste it. So do we have any common it's again, now it's the same thing as what we did in 2 by 2 systems. Is there a common factor? Look for a common factor. Yep. Second row has a common factor. And what is it? 4, 2, they're all even, so it's definitely probably works with a 2. So we can divide everything by 2, and that makes that simpler. Okay, it makes it simpler. So now, what do I have to do to each row to make the coefficients the same? So now I want to eliminate, this is y, remember, this is z. I don't have to worry about x because there's no x's in this. So if I multiply the first equation by 3 and the second equation by 7, right? And I'll keep the, I tend to just multiply by positives always, and then add or subtract as appropriate. So the first one here, I would multiply that by 3, and that one by 7, and that will eliminate now, you can see, that will eliminate the y column. So what do we need to do to eliminate y? Do I need to add row 2 and row 3 or subtract? Well, it looks like I have to add them. So row 3 becomes 1 row 3 plus 1 row 2. And look at this. Now I have, and it shouldn't have this third column, or that column, or that row shouldn't be in there. So now what do I need to divide by? That says 0x plus 0y minus 1z equals -3. So I need to divide that by -1. Okay, and now that tells me that my answer is, and I'll just write it over here, my answer there is z equals 3. So, oops, I should put z equals there, and then 3. So now how do I figure out y? Well, now I go back to the simplest equation I've got, go up, up, up until I get a simple equation. That looks like a pretty simple equation there. -7y plus 9x equals 55. It has fewer negatives. Yeah, it has fewer negatives. So for this, I could solve this equation. So it would be -7, right? And then I would be, did I figure out what y was? No, I figured out what z was. So negative 7y, and then I would be adding 9x. And what's x worth? Or z rather. Z is worth 3. Okay, and that would equal 55. I'd be solving that equation, right? So I'm substituting into row 2. Negative 7y plus 9z, but I know z is worth 3. So that becomes negative 7y plus 27 equals 55. Now I have to subtract 27 on both sides. And that would be 20. So now negative 7y would equal 28. Okay, and divide both sides by negative 7, and y would equal negative 4. Okay, y would equal negative 4. Now let's see how I'm doing, because I did put the answers everywhere that you have the answers. Oh, y is negative 4 and z was 3. That was right. Now I have to get x. Well, how do I go about getting x? Now I have to go back way back up. And look at this. There's the first formula right there for x. 1x plus 5y plus 4z equals negative 7. So what I do is, now I like to do this. I'll write 1x equals, and then what I do is, right away, I subtract that 5y and that 4z. Okay, and it's on the other side of the equal sign now. So it's going to become negative 5 of y, and y is worth negative 4, plus, well actually in this case it'll be minus 4z, and z is worth 3, right? And then I've got this minus 7 here. Minus 7. Again, I have to subtract. That's an equation, remember. That's x plus 5y plus 4z equals negative 7. So I have to subtract 5y and subtract 4z on both sides. And then if I evaluate that, I'm going to get 1x to be worth 20 minus 12 minus 7 is in fact 1. Okay, so what's the process? Get two equations with two unknowns, solve both of those, back substitute. Okay, so it's the same process every single time. Let's do one more that's like this, and this one we'll do a little bit faster, and I won't quite finish this one. I'll maybe let you do that because you have access to this system of equations as well. And so so what we're going to do here is okay, so I've taken here's the system of equations right here. Now this is a tricky one too. So we see it's 1x plus 2y plus 5z equals 23, and then it's just x and z here. Okay, it's just x and z. And what we have to do then is we have to make sure that we put the x's in the right place. I know the mistake I made even when I was doing this is I put a 4 here and a 2 there because I saw it as 4x. I saw it as 4y plus 5z, but it's not. There's 0 y's in each of those equations. There's 0 and 0. So, but do we have two equations and two unknowns in row 2 and row 3? Yes, we do. Yes, we do. Okay, so that means as soon as I see two equations, two unknowns, they have to go in row 2 and row 3, and I'm going to solve for those two unknowns. So it looks to me like there's no common factors there. 4, 5, 16, 2, 7, 26, 1, 2, 5, 23. So there's no common factors. And remember that I can go down to, actually I didn't even look there, I go all the way down to part C if that's where I was starting. So let's see, is that the right values? I'm going to have to take this right here and copy. Make sure you enter things incorrectly, the signs incorrectly. So there we go. So now I need to do this. So again, are there common factors within this row? No, no. So that's the first thing is common factors. The next thing we want to do is we need to get a pair of coefficients equal. how are we going to do that? Well, let's take a look at this. I think it might be pretty easy to do. This is a 4, this is a 2. Okay, this is a 5, this is a 7. So I could multiply this by 7 and this by 5. Or what about this one? I only have to multiply the third row rather, by 2. So the second row I can leave alone. The third row though I multiply by 2. Okay, and now notice that the x coefficients are the same. So now what would I do? Well, I'm going to take, and again ask yourself, so for this here, what would you rather have negative? Row 2 or row 3? Right? If you want to maintain positive numbers, you're going to have negative of row 2 plus row 3. Right? And that works here too. So it's going to be row 3 plus negative 1 of row 2. And look at that. We end up with, sorry about having that row there. Shouldn't have that. And then now what I'm going to do is divide everything by 9. Divide everything by 9. Okay. So that gives me z equals 4. And now when I back substitute, I know z equals 4. Now I back substitute that into this equation in row 3. Okay, so I would have in this case, I got z equals 4. So I have 2x equals, and then I'm going to have this 26 here is on the other side, 26, and I'm going to have to subtract off 7z minus 7z. And z we just figured out is worth 4. Okay, 26 minus 7 times 4. So 26 minus 28 is negative 2. 2x equals negative 2. And x would equal negative 1. Okay, now I go back and I would have to take that x and that z that I know, x and z that I know, and substitute it into row 1. And so this time I'd be solving for y. So what is that equation actually? So I'm going to isolate 2y. So 2y equals, and then if I look, I'm going to have that 23 to start. Okay, so 23 to start. I don't think I did that last time. 23 to start, and then I'm going to have to subtract off x. Okay, whatever that's worth. And then I'm going to have to subtract off 5z. Okay, and we know that x is worth negative 1, and we figured out z to be worth 4. Okay, so 23 minus negative 1 is 24. 24 minus 20 is 4. 2y is worth 4. And that makes y worth 2. Okay, folks, so that's how we go through that. And we've solved now for x, y, and z. 3 equations, 3 unknowns. Okay, so the next set of videos, we're going to go into a little bit more complex, where we're working where we don't have 2 zeros already, where we don't have 2 equations and 2 unknowns right off the bat.